My name's Derek. I'm going to talk to you about listening in kind of the third dimension. Show of hands, who remembers this? Yeah? You stared at that for a long time? I thought it was so cool when I first saw that. I wasn't listening to Lenny Kravitz at the time, but the visuals were just amazing. I spent a lot more time on this because it got really three-dimensional, and then I sort of lost track of it now with iPods, and I didn't really stick with just sitting in front of the computer watching these visuals for hours on end. Sort of grew out of that. But I was thinking recently about what it would take to actually make this respond to audio using the web. And it turns out it's actually pretty easy with a few ingredients. One, which you need for the audio part, is the Web Audio API. If you look at the audio tag in HTML5, it's right there in all your modern browsers. MDN has a whole bunch of great articles on how to use it, how to hook up filters, do all these wonderful things with analyzing audio. So that's ingredient one. Ingredient two is DonutJS. It's like the de facto standard for 2D and 3D graphics using WebGL. So if you want to make a game, if you want to do crazy data visualization, if you just want to have fun and hack around, it's an awesome library full of tons of tools to make those things happen in your browser, which is rad. And then the third one is just the ability to play around with it, have fun, break stuff, and see what happens. So I've got two demos to show you. The second one was the sneak peek, but the first one, these are both on CodePen, by the way. The first one involves listening to a sample music track. I'll sort of show that. I have it preloaded here. And what's going to happen is that these little sparks here are going to start responding to the audio. And each spark sort of has a different piece of that frequency that we're sampling. You can see the bass is there, and then when the drums hit, you can see the rest of them react, which is pretty fun to play around with it and see okay, this one gets that one, this one gets this one, and so this was pretty simple to make too, in terms of lines of code. This is all of it, all of the JavaScript needed, and a lot of this is sort of boilerplate. I'm going to run through probably a whirlwind tour of it, but I'll hopefully highlight a few key parts for you to look at later. And as I said, this is on CodePen, so you can play around, fork it if you like after. The main thing that we're doing for the audio analysis is, Is that good for everyone? Okay. It's really hard to see a cursor on a projector. So anytime that you deal with web audio, you have to have a source, and you have to have a context to store it in, and then you hook up an analyzer to it. So what I'm doing right here is DonutJS helpfully wraps a lot of this into their own framework, so it works with shapes, it understands the request animation cycle that sort of re-renders this every time. And so we grab the audio source here, we read it in to this buffer, or to the audio here, and then we set a loop. So if I were to keep playing this, it would just keep on looping. There are other controls like pausing and playing. You can hook into events, so when it does pause or when it does play, you can toggle this button state that I have here for the pause or play class. But yeah, that basically hooks into the audio piece of it. And the visual piece of it is this animate function. And this is getting called in request animation frame. I referenced that earlier. Request animation frame is run 60 frames a second, so 16 milliseconds. It'll keep on calling the same function over and over again, which is why it's sort of important to keep it tight and keep it quick. Otherwise, you'll get those laggy frame drops. There's some really sort of simple to read ways that we're rotating the sparks. This is happening regardless if it's playing or not. So this is the sparks rotating here. Whenever we are playing and we get down to setting the scale of each spark, like so, we grab that frequency data that's happening at each frame, read it into this bytes array, and do a quick sort of segment of each, every 2 elements in that array, pack it together, and just set the scale, and it's that simple. This is the X, the Y, and the Z. So I'm setting them all the same, otherwise you'd get some crazy skewing, which can be fun too. But those are the 2 big pieces. And you'll notice also I have the background here, sort of breathing. That was something that's not related to the audio, just a fun little experiment that happens in the animate function. Where's that? Here. The position just changes based on the current time. And what's really cool about this stuff is that you can pull out these variables, and once you have the framework, the sort of sketch of it in your mind, you can easily just change a value like that, and now we have 3 instead of the 30 rings. Or you can change the spark distance to be way farther apart. So it's pretty quick to sort of, once you have something down, hack around with it and play with it. So that's demo 1. These are links, I swear they work, but I wanted to load this before, in case the internet went weird. Demo 2 is actually responding to the noise in the room right now. So if you were to clap, all that stuff would go crazy. Yes. It stays up. And silence. So this one, what's great about audio sources is that they can be from anywhere. So there's also microphone sources. You can actually connect a lot of hardware. So for the microphone, I actually decided to get away from the built-in 3JS wrappers on this and just use it directly with this Navigator Media Devices Get User Media. And this also, I passed audio here because this also lets you get video. So if you want to use a webcam, you can easily grab that as well, transform that stream however you like. And then you just connect an analyzer to it, which where's the animation frame? The analyzer is that key piece again that's going to grab all of our information about what's currently happening with the sound. And so this is the animation frame here. So frequency is going to be that same array from previously that we read the sound information into while we're listening to it. And we split it up across all these. So if we make certain noises, certain shapes will be activated. So if I go certain shapes show up bigger than others. And this one's really fun to play with colors and shapes and size because you can make them super big. You can like make them pulsate and do super raver effects if you want, or you can have the camera fly all around or just do a sleep rotate. Like this is just no interaction whatsoever other than watching it with the microphones. There's no like actual tactile interaction with it, which is pretty fun. So it's like 2 whirlwind tours. I know there was a lot of stuff in there that hopefully the code pens, which I'll reference later, are great. But the important things that I found out of doing these and learning more about WebGL and audio stuff is that it's just a lot of fun to make. I also think about performance a lot differently, and it helps me professionally. Like when you're trying to get something rendering on a page fast, user interaction responding fast, it's the same problems you have to solve with making this not laggy when it responds to audio. What's also great is when you're in charge, you don't have to make it Internet Explorer compliant. You can tell yourself, hey, I'm done, I don't need to do anything more. And you can actually use any copy you like with the messaging and what have you, so it's cool. I like showing people this because tech, non-tech, doesn't matter. Anyone who sees stuff like this in like an interactive way always has like a certain reaction to it, and it motivates me to do more about it, and also like gives me a lot of ideas. So it's a lot of fun to see how people react to this stuff, especially being on the web where someone can just pull out their phone and look at it there. There are a lot of times where I had that Chrome dead-eyed folder pop up, ran out of memory, had to restart my Chrome session, but that's all part of it. That's all the fun part because you're in charge and you can say when you're done. So yeah, that's my talk.